Decades of extensive paleontological and geological investigations have gone into documenting the natural history of Mississippi and the rest of the Gulf coastal plain. However, this quest for knowledge is far from over.
So go ahead and explain to me what the Mississippi embayment is and why it's different than the Western Interior Seaway.
So the Mississippi embayment is next to the southernmost region of the Western Interior Seaway. And a lot of times it gets lumped into the Western Interior Seaway, but it's technically its own separate thing. For that to make more sense, the Western Interior Seaway was a shallow sea that split the North American continent in a western and eastern half during the Mesozoic. There was a section in the southeast where it came up a little bit further on land than in other regions. And so nowadays we know that as the Gulf coastal plain area, and more specifically the Mississippi embayment, because all of this state of Mississippi that we're in was completely underwater during that time. And even when the Western Interior Seaway started to close, aka the water started to recede, and essentially the continent started to look more like it does today, dry land, the Mississippi embayment was one of the last things to fully dry up, so to speak. And so some of what ongoing research is, looking into is that each bay area, right, each region where the ocean is in contact with the continent, the main continent with land, have their own very, very specific and very unique ecologies and type of life and conditions, and that varies a lot on different characteristics and different conditions. It's entirely possible that the embayment region in Mississippi had its own unique differences and characteristics in relation to the Western Interior Seaway. But it was certainly, at the very least, a very similar shallow marine environment.
Understanding a region's natural history is an ongoing process that constantly requires the acquisition and revision of data, and site-specific characterization and analyses are important when compiling the information that would help build upon this knowledge. A lime quarry in Clay County, Mississippi is an example of such a site, which, until now, has not undergone any formal research. If we took a dive into Mississippi's ancient history, you could say we would be taking a much more literal dive underwater. The exposed layers of rocks at this quarry represent a slice of time beginning roughly 75 million years ago, a time when this environment was much like that of a shallow sea. Now, the ocean has been home to many unique forms of life over the millions of years that life has existed on this planet. Even today, we see an incredible abundance of fascinating life forms in ocean ecosystems. However, most of this diversity is limited to an area called the continental shelf, or the edge of the continent that lies under the ocean. Think of this kind of like the shallow end of a swimming pool. This is the type of environment that we would have seen here in Mississippi during that slice of time that I mentioned previously. The rocks that formed during this time are now being mined for lime, and no, I didn't mean for that to rhyme. Lime is a material that has a wide array of industrial and agricultural applications, but these same rocks also offer glimpses into the distant past. Preserved in their layers are fossilized remains of what was once a vibrant ecosystem, which now, in many ways, is a hollow shell, or rather, many hollow shells, of its former self. But even these are mere fragments within the vast mosaic of our planet's rich history. Imagine the layers of rocks as though they were chapters in the storybook of time, and the fossils as the main characters within them. Through my research on this site, I hope to portray how these fragments comprise a piece of the never-ending puzzle that is natural history, and how the prehistory of this region fits into the larger framework of an ever-changing natural world.
An oyster's morphology can actually be a tricky thing to study sometime because their form tends to be affected with the type of substrates that they attach to. So a good example is this Cretaceous oyster. A lot of times these little oysters, when they're oyster larvae, would attach to other species of oyster as their substrate. And as they grow, they tend to kind of grow around that surface. You can actually see the remains of an oyster that this guy attached to. The base here is kind of small because this specific surface that it attached to is small. Whereas here you actually see a much clearer image
This is an anoceramid that is a giant clam, and the Pycnodonte would have attached to this guy, growing up like this. You could see that all of this, it would have had to grow around this surface, and you don't see that same thing here. Now, this is just one example, but there's actually a lot of examples where one type of oyster could actually look drastically different from many others of the same type.
This is another example of the encrusting behavior. It's only the left valves that attached, so if you know the valve of the species that you're looking at, you can assume that, for instance, if this oyster down here is an acute Osteria plumosa, if this were to be the left valve, then it would have been attaching to this oyster shell like this. However, it's also possible that if this if this shell of unidentified bivalve, right, you know that this shell would have had to be the left valve if it attached to the plumosa, because it's only the left valves that would attach to the substrate. So the Dimopolis Formation is a local formation in the Gulf Coast Plain with exposures primarily in Alabama and Mississippi. There's also some transitioning, some sedimentary transitions between chalk and marl, and really what that's kind of getting at is how argillaceous or silty certain layers are as opposed to others. So that formation formed during a period of pretty massive transgression, which means sea level rise. So the sea levels within this region were rising at that time, and this is reflected in the various sedimentary sequences that we can see within this area. Remember, this was a period of time where this region was entirely underwater. The Mississippi embayment was a shallow marine environment. This was roughly 75 million years ago, during the late Cretaceous, and what we would have seen there is similar in a lot of ways, but then also different in a lot of ways as what we would see in the shallow marine settings of the continental shelf of our modern day Earth. So this typically ranges to about 200 meters in depth. There's a lot of biodiversity that actually exists within the zone. In fact, some of the most biodiversity exists within this specific type of oceanic environment. And so what we would have seen is a ton of benthic organisms and epifaunal suspension feeders, and that's fancy words for bivalves. So all of our clams, oysters, they existed for a really long time, much longer than us, and they were very prolific back then as well. But a lot of the ones we would have seen back then are actually quite different than the ones we see around now. So we have very unique different types of clams and oysters that would have lived during that time. We also have sponges, corals, and of course all of our fabulous marine predators. Sharks were pretty abundant back then. There was a specific type of shark called Squalicorax, or commonly called the crow shark, similar to the tiger shark nowadays, and our famous massive marine reptiles. So the Mosasaurs and the plesiosaurs would have been pretty abundant around this area too. All in all, it was a very, very dense and very, very rich diverse ecosystem, and that's told alone by just the massive amounts of remains at this site. What these remains tell us even more about that ecosystem was the fact that, due to preservation bias that's inherent in the fossil record, we know that this really was only the tip of the iceberg of the fauna that existed at the time. So we know that even as diverse and vibrant as these deposits indicate that the ecosystem was, it would have been even more vibrant and dynamic than we may have been able to imagine.